C++ templates is a powerful way to define general-purpose classes. Certain types of classes are found to be so useful that they have been made available for C++ programmers in the form of a standard templates library, or STL. The STL allows us to import many useful classes and methods to define useful data structures, such as vector, list, map, as well as algorithms and iterators. We've already worked with some STL class templates in previous sections, such as IOStream to manage input-output functionality, string to manage string manipulations, and ctype to manage your character manipulations. You can always search online to find the full list of STL available in C++. As an example, here's a website that lists the C++ set of libraries that are available, each of which can be imported through a hash include header file, so stdlib.h for example. And every element in the library is defined within this std namespace. So for example, when we used cout is part of the hash include IOStream library, and cout is an object that lives within or sits within the std namespace. And so typically, if you are looking for a particular kind of function and you feel that, or you sense that it should be a common function, you can't be the first one looking to use such functionality, then the odds are that it's defined in one of the standard template libraries. So for example, on the left here, there's a full list of different libraries you could use. There's a ctype, which manages characters and helps handle character functions. So for example, if you wanted to know if a character is alphanumeric, there's a function isAlnum. If you wanted to know if it's alphabetic, you can use this function as alpha. If you wanted to know whether it's lowercase, you could use this isLower. There are many, many different libraries. If you wanted to do mathematical operations, we saw earlier you could use, if you wanted to use power or exponent, logarithm, you can import those functions from the CMath library. If you wanted to work with different types of data structures, there are several libraries to help with that. If you wanted to do input-output, reading or writing from the console or from a file, we saw fstream. We worked with fstream before to read and write to files. If you wanted to do different kinds of processes or you needed threaded functionality, there are some libraries that can help with that. There's libraries that help with, for example, random number generators. So if you wanted to generate a random number, there's functions for that. If you wanted to deal with regular expressions, you wanted to do some substring keyword searches, you could use this library. So there are many, many, many different libraries. It's hard for one person to know all of them. So if you're ever in doubt and you're looking for a particular kind of functionality, definitely search online. And it's likely that it'll be part of a library, and your Google search will help you figure out what function should you be using and in which library does it exist and which library should you be importing to do that. So let's look at a new library, the vector library, and we're going to do some very simple, very basic vector manipulation kind of stuff. So I'm going to start off with importing hash include vector, and I'm going to initialize a vector that can take in integer values. We can store integer values with the variable vec. Let's say I wanted to display the size of the vector, so I could do cout vec.size and line. So what we can see right away is that vector is an object, and it has a method .size which returns the size of the vector. Currently it's 0, it's size of 0 because we haven't added any elements to the vector. Let's say we wanted to add 5 values to the vector. We can do this in a for loop, so for int I equals 0. I less than 5, I plus plus. We're going to use our object vec dot, and there's a built-in function called pushback, which inserts elements into the vector, and we're going to add elements that are multiples of 3. And if we wanted to see, let's say, the new size, the updated size, we can do so by calling our vec.size function. So we can see that now we have 5 elements in the vector. Let's say we wanted to print out the elements of the vector. We can also do, so this is adding elements to vector. And we wanted to access elements of vector. We can do so again with a for loop. So for int I equals 0, I less than 5, I plus plus. And we can print out the vector by accessing the ith element using the index I. We can add that. And as you can see, we've just iterated through our vector, and for each index we've printed out the value at that index. So index 0, the value is 0. At index 4, the value is 12, because 4 times 3 is 12. And the last thing we're going to look at is using an iterator to access the values. So what we can do is define a iterator, and usually we would do this because this is a very quick way to access the elements. So we're going to define an iterator. B equals v vec.begin. So vec.begin returns a kind of pointer. So what we can do is loop through while v does not seem to have reached the end. And so there's a function that just helps us check whether v is at the last value or not. And v will automatically iterate through. So we don't have to define this formal int I from 0 to 5 and plus plus. All this happens within our iterator variable. Cout value, and we can access it using our pointer object, and we can increment our iterator. So what's happening here is that we're basically defining an iterator object, which is just a pointer to wherever our vector exists in our memory system. And we're going to loop through it until we've reached the end. So there's a function that helps us figure out whether we've reached the end of that iterator or not. And to access the element or the value that the iterator is pointing to, because it's a kind of pointer, we're just using this asterisk to access the value. And we're going to increment using v++. And as you can see, I'm just going to make this neater so we can see iterator. So run this again. We can see that we've iterated through v, and we've pulled out the elements of v using an iterator to access the values. So this is another way we can loop through a vector, especially if we don't know or don't want to retrieve the size of the vector. And so what's really nice about this, about using a lot of this functionality with standard libraries, is, as we saw with this vec.pushback, it handled allocating the size to the vector. So we didn't have to tell it we want a vector of size 5. It just figured it out. And what's nice is that there's a method built in to retrieve the size if we wanted to know the size of the vector. We can very directly loop through the vector as we would with an array and extract the values. But alternatively, the standard library has built-in functionality to iterate through our vector. And again, if you wanted to know all the functionality within this vector library, we'd go back to a reference that includes information on the vector library. So we can look at our containers. So within our set of data structures, we can click vector, and we can look at the different functions that are available. So for example, .begin and .end, iterator to beginning, iterator to end, it's a function template. We can look into this vector template, and you can see it's defined, it's within the std namespace, std : and it's a template of class vector, takes in some generic data type t. It tells you what are the parameters, the template parameters that can be defined, and it tells you some of the member functions that exist. There's a constructor, destructor, that's a public member function. There's also iterators. If you wanted to do not just the iterator that we worked with, but you can reverse iterate. So return reverse iterator to reverse beginning. And if you wanted to figure out the size or max size, if you wanted to change the size, there's a functionality for that. If you wanted to test whether the vector is empty, there's an empty function you can access. And if you wanted to modify the vector, there's a number of functions to help with that. So we use the pushback, which added elements to the end of the vector. You can also delete the last element using popback. You can insert elements, erase, swap. So there's many different functionalities you can use, and typically these are optimized for C++, and it abstracts away a lot of the heavy lifting that you would need to do if you wanted to implement your own.